Namaste to all. Today I will explain about telescopes. This is the agenda of our topic. We will learn about light year, two types of telescopes, spectrum, and types of non-optical telescopes, and we will conclude. First of all, we need to know what is a telescope. A device which is used to see distant objects magnified, which means if you are seeing a far object, if you want to see it magnified, we use telescopes. People use telescopes to magnify celestial objects, and these are the images which is formed by the telescopes. We can see magnified image. Basic distances and units. Now, telescope is a concept of physics, so we need to know about distance, time and speed. Distance. In our real life examples, the distance between two places we use kilometers, and length of the scale or pencil we use centimeter. And if you're running a marathon or running race, we use meters. And if the distance is too high, like 100 kilometers, if it goes more than that, we use separate units for that. Approximately, the distance between Earth and Sun is really high, which we can't measure using kilometer. So we use a specific unit called light years. Now we will learn what is light year. What is a light year? Light speed is 3 into 10 power 8 meter per second. Light year is the distance travelled by light in 1 year. 1 light year is approximately 10 trillion kilometers, and the light travels 10 trillion kilometers in 3 into 10 power 8 meter per second, which is really fast. And sun's light rays, from the sun to the earth, it takes 8 minutes. The light rays from the sun to earth takes 8 minutes. So if you're seeing the sun now, it is actually 8 minutes before, because the light rays took 8 minutes time to come to the earth. From this we conclude that time is relative. Now we will learn the two types of telescopes, optical and non-optical. Optical, the word optical means eyes. So the telescopes which we use, which we can see, from which we can see the images exactly by the eyes. The optical telescopes use lenses or mirrors and focus the light rays at one point, and we can get the image of that object which we are focusing. But non-optical telescopes, they do not use any lenses. They use, they sense the signals like X-rays, gamma rays, radio waves through detectors. They use sensors or detectors to detect those rays. Optical telescopes. Optical telescopes use a simple lens to get the image of that object. This is a simple diagram of that. The light rays enters into the telescope and it is focused at one point. In that focal point, that image is formed. Through the eye, we can see that image which is formed there. And Devastal Optical Telescope, which is in Nainital, Uttarakhand, it is the largest optical telescope in India. You can see the image here. And the world's largest optical telescope is Gran Telescopio Canarias, which is located in Spain. Spectrum. This is a very important topic because the white light which we see everywhere around our world is dispersed into 7 lights, which is here. These 7 lights and the white light is only visible to our eyes. So optical telescope works on the range which is visible to our eyes. But radio telescopes and gamma ray telescopes, X-ray telescopes works on the principle of non-optical, because we can't see those rays by our naked eyes. And radio telescopes are used in the radio waves in our daily life, and X-rays are used in the medical purposes, and gamma rays are used in nuclear projects in many industries. Radio telescopes. These radio telescopes actually use a large parabolic dish which look like this, and the radio waves enter into this dish, and the rays are focused at one point, and from that point the image is formed, and scientists use that image. Parabolic dishes collect the radio waves and focus them, and radio waves can be located in ground or space. Example, Hubble Space Telescope is located in the space, which senses these radio waves. And for example, Parkes Observatory in Australia is located in the ground, and in India, giant Metravi radio telescope, which is in Ooty, and usually found in deserts or mountains, because due to light pollution, these radio waves might get affected, so they are located out of the cities. The next one is X-ray telescopes, and they use a specific mirrors called nested grazing incidence mirrors. You can see these nested grazing incidence mirrors, which converge the red light X-rays into one point. And X-rays are collected to study about black holes and supernova. Supernova is the explosion of star, which you can see here, and this is an image of black hole. They are located in space. We can't do it in ground because X-rays are very sensitive to our atmosphere. And example, Chandra X Observatory, which is done by NASA, it is in the space. The next one is gamma ray telescopes. Uses atmospheric Cherenkov technique. This is a technique in which they use charged particles to detect these gamma rays from our atmosphere, and collection of gamma rays helps us to study about pulsars, black holes, and gamma ray bursts. Pulsars, rotating stars which emit more high energy, which will reach our Earth. See, this is an image of a pulsar where the two stars, due to their gravity, they attract each other and start to rotate. And gamma ray burst, this is an image of gamma ray burst. It is the most powerful burst in the universe, which is caused due to the collision of black holes and stars. And they can be operated in both space and ground, like radio telescopes. And examples are they are located in Hanle in Ladakh, which is called as Indian Astronomical Observatory, and in space it is run by NASA, which is known as Fermi Gamma Ray Telescope. The next unit which we are going to learn is parsec. Parsec is also an astronomical unit. 1 parsec is approximately equal to 3.6 light years, 3.26 light years. And here this is our whole universe. And see these units, 1 billion light years and 1 billion parsecs. The whole universe is 93 billion light years, which is 28 billion parsecs. And yeah, if you see here, this is our sun and Proxima Centauri. The closest star is the Proxima Centauri from our Earth, apart from sun, and which is 1.3 parsecs away from the sun. These are some stars around us. Here a word is mentioned called as galactic center. Now we will learn about it. Galactic center. This is the center of all the galaxies. There are many galaxies which are surrounding to that. We saw here sun and galactic center. So the sun is located somewhere here, not exactly here, but around this galactic center in one galaxy, the sun is located, and around that sun we all are living. Imagine how many galaxies are around this, and this is really interesting. And we have come to the conclusion. Galileo Galilei, a famous astronomer, was born in Italy, Pisa. He has invented the structure of telescope, and he was interested in physics. He initially created a telescope which can magnify a far object 30 times bigger. And through some corrections, he created a telescope which could even tell an image of the moons of Jupiter and the rings of Saturn. Galileo Galilei has done this. He has used only optical telescope because during those days there were no technologies. And in 2022, a group of radio telescopes called Event Horizon Telescopes discovered the presence of a black hole in our Milky Way galaxy. So the image formed by the Event Horizon Telescopes would be like this. This is the image of the black hole which is formed, and this Event Horizon Telescopes, radio telescopes, is not does not belong to one space organization like ISRO or NASA. It's like a global collaboration of all countries, and these are located in several countries in the world. And thank you. I hope you people enjoyed and understood this. Thank you.